In this video, I'm going to go over how to do the first three problems of the Unit 7A and 7B review packet. Alright, so looking at this first one, I look at this equation and I'm trying to figure out what form is this equation in. We have three options. We have vertex form, intercept form, and standard form. Now for this one, it actually could be two different forms. I could either think of this as y equals a times x minus h squared plus k, where I see just one thing being squared and say it's vertex form. Or I could say, well, I don't have any parentheses, I just see an x squared, it must be standard form. Personally, I think it's easier to look at this as vertex form because I can identify the vertex right away. So if this is y equals a times x minus h squared plus k, I know that a is equal to 1/2. I know that h is equal to 0, and I know that k is equal to -5. In other words, that -5 translates the graph down 5 units from the origin. So the vertex is going to be at 0, -5. And I can plot that point. 1, 2, 3, 4, 5. And there's my vertex. In order to get the rest of the shape of the graph, I need to create a table. So I'm going to do that right here. I have x. I'm going to do a little bit of work in the middle, and then I'll get my final y coordinate. In the middle of my table, I'm always going to put my vertex. So we have 0 and -5. And then I want a few other points that are going to help me get the shape of this graph. So I'll start off with 1 and 2 and just see where we go. If I have 1/2 times 1 squared minus 5, well, if I do order of operations, 1 squared is 1, 1/2 times 1 is 1/2, 1/2 minus 5 will be -4.5. So I can go over to 1 and -4.5 and plot that point. Now I can either substitute in -1 for x and evaluate that, or realize that this is going to be symmetrical, so this also has to be -4.5. So I get that guy over there. I can substitute in 2. 1/2 times 2 squared minus 5. Well, 2 squared is 4. 4 times 1/2 is 2. 2 minus 5 is -3. And I know that if I go on the other side of the table, this must be symmetrical. So I can go to 2, -3, -2, -3. And I personally would love to get another point just because they're all pretty close together. So I'm going to substitute in -3, or I could substitute in 3. It doesn't really make a difference. And when I substitute in -3, I have 1/2 times -3 squared minus 5. Well, I know that -3 squared is a positive 9. Half of positive 9 is positive 4.5. 4.5 minus 5 is -0.5. And again, the table is symmetrical, so I'll have the same point over there. And now that gives me a little bit better picture of what this graph looks like, and I can connect these points to form my parabola. There you go. The only things left I have to do are the axis of symmetry, domain, range, and transformations. Well, I know that my axis of symmetry goes right down the middle of the graph. I'm going to use a pink highlighter in order to show that. That guy right there is my axis of symmetry. It will have the equation x equal 0. I also need to figure out my domain. I know that my domain are all the x values, and when I look at the graph going to the left and right like the x values do, this never stops, so this ends up being all real numbers. The range is all my possible y values, and when I look at this graph, I see that the y values, we go down to when y is -5, and then it goes back up again. So the lowest y value is -5, or it's anything above that. So to say that, I will say y is greater than or equal to -5. And then my transformations. I have to think through which each part does to the graph. I know looking here, I didn't translate left or right at all. That was h was 0. But I did translate down 5 because we had that -5 at the end. So I have translate down 5 units. Make sure we have the word translate. I need to make sure I know that transformation. We don't want to just say down 5 units. Then this 1/2. This 1/2 being multiplied out front it made this graph rise less fast than the parent function. In other words, it makes it a little wider, and the mathematical word we use for that is called a vertical shrink. And I'm going to put it in parentheses wider so we know that that means the same thing. And now we have finished number 1. Moving on to number 2. I look at number 2 and I see 2 sets of parentheses. I see 2 x's, neither of them are being squared, so I know that this would be intercept form. Now in my head I'm thinking, well, how do I graph a function that's in intercept form? Well, when it's in intercept form, the name kind of helps me out figure out what I can find from the equation. I can find the intercepts right away, so that's my very first step. So step 1, find the x-intercepts. To do that, I let y equal 0, so I have 0 equals 3 times x minus 5 times x minus 7, and I know that I need to use the zero product property in order to solve this. Well, I could say 3 equals 0, but there's no way 3 equals 0, and there's no x to solve for. I can set x minus 5 equal to 0 and x minus 7 equal to 0, and when I do that, I recognize that x equals 5 and x equals 7. So my x-intercepts are 5, 0 and 7, 0. So I'm going to go over to my graph right now, and I'm going to plot those x-intercepts. 1, 2, 3, 4, 5, 0, 1, 2, 7, 0. So we got 5, 0 and 7, 0. Now, I know that no matter what form the equation is, at some point I got to figure out what the vertex is. So I'm thinking through what I'm given. Well, right now I have the x-intercepts, and I know that the vertex is going to be in the middle because our graph is going to be symmetrical about the line that contains the vertex. So I'm going to go right smack dab to the middle, and that's where my axis of symmetry is. I could just look at the graph to recognize the axis of symmetry. I see that that's where x equals 6, or I could find the average of my x-intercepts. So my axis, step 2, my axis of symmetry, I've already got it from the graph, but if I wanted to do it by hand, I could say that's 5 plus 7 divided by 2, or x equals 6. So axis of symmetry is x equals 6. The whole point of finding that is because I know my vertex is on the axis of symmetry. So I know that it's on the axis of symmetry, which means that the x-coordinate of the vertex must be 6, because it's got to be on this line. So it's 6 comma something. I just got to figure out what the y-coordinate is. Well, fortunately I have an equation that relates the x and the y coordinates for this function. So step 3 is to find the vertex, and I'm going to do that by substituting in 6 for x. When I simplify this expression, I get that the y-coordinate is -3. So my vertex is 6, -1, 2, 3. Now, if I wanted some extra points, I could do that as well, substitute in. Unfortunately, those points are not going to fit on this graph, but if we had a bigger graph, we could find more points. The only things left that it wants us to do are find the domain range and the transformations from the parent function. The domain, again, is all real numbers because the graph does not stop going to the left or the right. The range is the y values, and the y values are not all real numbers because we do see that this graph has a minimum. That minimum value occurs at the vertex, and we see that the y values go all the way down to -3, or they're anything above -3. So here, the range is y is greater than or equal to, not -5, -3. The transformations from the parent function, well, I look at the vertex, and I see the vertex for the parent function is at 0, 0, but we're now 6 to the right and 3 down. So my transformations, I know that I translated right 6 units and down 3 units. However, I know that my a value is 3, and when my a value is 3, that's going to make this graph rise faster than the parent function, whose a value is 1. So because it rises faster, we get narrower, and when we get narrower, that means we vertically stretched that function. So this is a vertical stretch, or in other words, we are narrower than the parent function. And then finally for the front page, number 3, I'm looking at this equation and I recognize that there's parentheses being squared. So when I see something being squared and there's nothing else going on, I know that that is vertex form. And just like before, I know I need to make a table for vertex form, and I make that table all around the vertex because I can identify the vertex right away from the equation. I look at this and I recognize that my A is -2, my H is -5, and my K is a +3. Remember that the H is opposite the sign in the parentheses because the vertex form is x minus h squared. So now my vertex is going to be -5, 3. In other words, that +5 translates to the left, 1, 2, 3, 4, 5, and that +3 translates up, 1, 2, 3. So there's our vertex at -5, 3. I need to make my table. So here's my x, here's my y. We're going to put that vertex right in the middle, -5, 3. And then I'm going to make everything else around the vertex. So if we increase, we'll be at -4, -3. If we decrease, at -6, -7, -8. And let's just start off here. If I have -2 times -4 plus 5 squared plus 3. Okay, we're going to do some mental math. -4 plus 5, I know that that is 1. Doing order of operations, 1 squared is 1. 1 times -2 is -2. -2 plus 3 is a +1. Now I could do the same here, but I know that the table is going to be symmetric about that 3. So I'll just fill that in. And I can substitute in again, -3 for x. -3 plus 5, that's 2. 2 squared is 4. 4 times -2 is -8. -8 plus 3 is a -5. And again, I can substitute that in there. So let's start plotting these points and see what it looks like. We have -4, 1. Then we also have the 1 on the other side. We have the -3, -1, 2, 3, 4, 5. And we can reflect that over the axis of symmetry. And it doesn't look like we really need any other points to get a good shape for the graph. There's our graph. The axis of symmetry again, because we didn't need to find it in order to graph it, I'm going to underline it just to show where it goes. It's right through that vertex. It's that line that if we folded the graph over on itself, it would land on itself. So that equation, that's a vertical line, and every point on this line has an x-coordinate of -5. So this is the line x equals -5. The domain, again, is all real numbers because our x values go from all the way from -infinity to infinity. And the range, this time when we look at this, we're going all the way up until we hit a y value of 3, and then we go back down. So what we're noticing is that this graph does not have a minimum, it actually has a maximum. So the highest value is 3, and then it's anything below 3. So the range this time is y is less than or equal to 3. And there is all the work for the front page of the review packet.